Today we're going to look at 5.4, which is on solving special systems of linear equations. So when we talked about solving systems graphically, usually we had two lines, and they always crossed in one spot. But when you draw two lines, what else could happen besides having the lines cross in one spot?
They intersect.
Well, these intersect, so in exactly one spot. But is there any other way you could draw lines that they don't intersect in one spot?
Parallel.
Yep, exactly. They could be parallel. In which case, where do they cross?
Nowhere.
They don't. So what do you think the solution would be?
No solution.
Yeah, that kind of problem has no solution. And then there's one other case we'll talk about when we draw lines. Okay, but there's three different cases. All right, so you guys have this, I think, on your guided notes, where it says solutions of systems of linear equations. So we're going to talk about the different things that can happen, and there are three. There are three things that can happen. So it says a system of linear equations can have, and this is what you want to write down, one solution, no solution, or an infinite amount of solutions. And this is true no matter what method you use to solve it. Okay? The method doesn't matter, but we're going to look at it graphically so you can see what each of these look like. Yep.
So would infinite solutions be like one line is directly above another line going in the same exact direction?
Yep, that's exactly what infinite would be. Two lines right on top of each other. Yep. So the one solution, that's what we've done a lot this week. So you guys have a grid, or you got a graph, three graphs right below it. On the top of the graph, you can write one solution. And then on the bottom of it, you can write the lines intersect. Okay, so the lines intersect. Now, no solution, I just kind of drew that one with you. Anyone remember, what did the no solution look like?
Parallel.
Yeah, we had two lines that were parallel. So if you try to solve a system, and you draw the lines and they never cross, that's a no solution. And then the last case is infinitely many solutions. We kind of just said what that one would look like. What did we say infinitely many would look like? Right, because it's where the lines cross. So if you have two lines right on top of each other, that means the lines are exactly the same, and that's infinitely many solutions. Does everybody have the three cases filled in for the graphs on the guided notes? Okay, so I think the two methods we're going to look at today are substitution and graphing. You can use elimination as well, all right? But I think for today, we're going to focus on those two. All right, so how do you know what method to use? Okay. I guess we could throw in an elimination one. It'll depend. It'll depend on how the problem is set up. In general, we want to use the easiest method we can. All right. So if the problem is set up x plus or minus y equals, and then a number. Elimination would probably be the way we want to do it. Can somebody give me an example of an equation that's set up in that form?
Y equals 8x plus 9.
So that would be for graphing. That would be y equals mx plus b. So that's good for that, but not for elimination.
Oh, 9x minus 2y equals 4.
4, yep, perfect. So that would be 1. And can somebody give me another equation in that format, but different numbers?
12x
Yeah,
plus 7 equals 10.
7
Y
y
equals 10.
equals 10. Yep. So if you had a system that looked like this, elimination would probably be the way we want to do it, so we can get one of the letters to cancel. No. All right. What if it's already in y equals mx plus b? Well, if it's in y equals mx plus b, you have two options. When you're doing substitution, you want to get a letter by itself. And when you're graphing, you also want to get y by itself. So if they give you graph paper, or they give you a grid, then you know they want you to graph. And the directions would probably say graph. Okay, so you could do either method. If it's in y equals mx plus b form, we'll graph it if they give us graph paper. If not, we'll do substitution. All right, and let's just do a quick problem. So this won't be example 1, but I don't think we reviewed elimination in the warm-up. So let's just do one with elimination. I don't want to do the one that's up there. That would be a hard one to do. Let's do something like 2x plus 3y equals 5. And let me do...
Is this example Y?
no, this is just one we're going to do together. 4x minus 3y equals 7. Okay, so if I wanted to do elimination, we have to make sure that we have same this, different this. Does anybody remember? Same
Numbers.
Same number, yep.
Same sign.
Same
Letter.
same letter, and then different sign. Do we already have same number, same letter, different sign here?
Yes.
Yeah, so this is the easiest case. We just add them right up. Okay. When you add these up, which letter cancels out?
Y.
Yep, the y's are gone. And you're left with, what's 2x plus 4x?
6x.
6x. And what's 5 plus 7?
That must have be 13. 12, sorry, 12.
12. Okay, so we get 6x equals 12. And now what would be your last step on both sides?
Divide.
Yep, what would you divide by?
6.
Yep, divide by 6. And what would you get for x?
X equals 2.
Yeah, so you get x equals 2, and then you plug that back in to find y.
The Y.
Find the y. Yep. Because I'm not going to finish that one up, but that's elimination. Okay, that's the easiest case. All right, so now let's try an example. Okay, and this time you get a much bigger graph than you had before. Okay, Okay, so they want us to solve this by graphing. Okay, so solve by graphing. Now, what's the y-intercept in the first one?
12.
12. Okay, we don't have enough room to go to 12. So what do you think we could do on our y-axis to make more room?
Count by twos.
Yeah, we could just count by twos, right? That'd be one way to do it. So let's make this 0, 2, and then 4, 6, 8, 10, 12. Oops. 14, 16, 18, 20. And we could go by twos. You know, if we're going to go by twos on the y, it's probably easy to go by twos on the x as well, just so we don't get mixed up. You don't have to. You could go by ones on the x, but let's just go by twos on both. Okay. Now, are both these equations in the right format?
Yes.
Yes, they are. Perfect. Okay, what's my y-intercept for the first one?
It's like the dot and 3.
So what's my y-intercept?
3x plus y.
Not quite. You want to help her out? What's the y-intercept in the first one?
12.
12. How do you know that?
It's the only number that's paired without a letter.
Right. The y-intercept, when you write your equation in this format, is whatever is right there. That's your y-intercept. So where do we put a dot for the first one?
12.
Yeah, I'll just put a key here. I'm going to do this one in black. So we put a dot on 12. And what's my slope?
3.
Yeah,
Over 1.
my slope is whatever number is in front of it x. Okay, so that's my slope, but we need it as a fraction. And what did we just say it was?
3 over 1.
Yep, 3 over 1. Okay, so Lily, from 12, how do I get to another dot?
You would. Wait, what?
So how do we graph this line?
Wouldn't it be like? So you're saying from 12 to the other one.
So how do we, I just want to graph y equals 3x plus 12, and I got my y-intercept already.
So you have to get your x, right? Yeah.
Mhm.
So wouldn't it be in between 4 and 2? Well, 1 go up 3.
So you're going to go up 3, yep,
Yeah. And over 1.
and which way is over?
Right?
To the right, yep. So you're going to go up 3 and right 1, but remember, our graph goes by twos. So if you go up 3 from 12, what number would you be at? 15. And then we have to go right how much? Right 1. So that's up 3, right 1. Okay, you go by twos, that's how it looks. All right, let's do it again. If you go up 3 from 15, where would you be? 18. And then we have to go right how much?
4.
Go right 1, which again on our grid is a half a block. All right, and I'm going to do that a little bit the other way, just so I get a better line. So what ends up happening on our grid is we go up 1.5 and right 1/2 because of the way we scale it. Okay. So I'm going to go down 1.5, right 1/2. I'll do it again. Down 1.5 and then right 1/2, and then down 1.5, and right 1/2. Okay, so now I got a bunch of points, and I will make my line. Oh yeah, that point was a little off. Sorry, should have been right there. Now it looks good. Okay, so let's draw our line best we can. Okay. All right, so there's my first line. Okay. How am I going to do my second line? What's my y-intercept? So that's my slope. Slope is the number with x. But what's my y-intercept? 6. So I'm going to put a dot on 6. Okay. And what's my slope this time? As a fraction.
-1.
Yep. So we have to go down 3, right 1. Okay. So if we're at 6 and we go down 3, where would we be? Yeah, just saying. So if we're at 6 and we go down 3, where would we be? Yep, we'd be at 3. And then we have to go right how many? 1, which is half a block. So now just try to repeat that a couple times and we'll see if we can figure out where they cross. Okay, so down there, and then right 1, and I'll try to do it one more time. So I'll go down there, right 1. Okay, do those red dots look like they're in a pretty straight line? Yeah. That looks good. Let's make our line. Okay, so this time, actually I think that one looks pretty good. All right, so let's zoom in and see if we can figure out where they cross. Where do you think they cross for the x?
A little over there and a half.
Where is it?
A little more than a half.
Well, let's try to round it to where we think the closest number is. To me, it looks like it's right, I would say right in the middle of that box. So what would be my x value?
0.5.
Careful, not 0.5. 0.5 would be like right about here. That would be about 0.5. Let's see, what's our x value there?
Is it like where the lines cross?
Yeah, so we're looking for the x value where those cross.
Is it like 9?
So an x value of 9 would be over like here. If the x value was 9, we'd be over there. No, not 0. If it crossed at 0, they would be right there.
Wait, would it be like 0.5? Like -0.5?
So this graph goes by 2, right? So we've got to look at the scale of our graph to interpret where they cross. So what's the coordinate of this point right here?
Are you looking at the scale like going that way or like up?
Well, it goes by twos on both the x's and the y's, and we just want to know what this location is right there. So we went left and we went up. How far left did we go?
By 2.
Negative 1, yes. We went left 1 unit.
But I thought it was just by 2s.
Well, if we were here, this would be 0. If we were here, this would be negative 2. We're in the middle. We're in the middle of 0 and negative 2. Because that would be negative 2, and that point would be 0. So we went left 1. And then how many up?
9.
9. We're in between 8 and 10. So I would say the answer here should be negative 1, comma 9. Right, let's check it. If we plug in negative 1 for x, what's 3 times negative 1?
Negative 3.
Negative 3. And what's negative 3 plus 12?
Negative 16. Wait, was it negative?
Negative 3 plus 12. 9. And that's exactly what we were supposed to get. So yeah, it worked in the top one. And if you plug it in the bottom, you get negative 3 times negative 1 is 3. 3 plus 6, 9 again. So that is the answer. Okay, so if you don't want to scale by 2s, because that's kind of confusing, that's fine. You're going to need bigger graph paper. Okay, you have to have graph paper that goes up to at least 12 to get a y-intercept. Yeah.
Thanks.
Yeah, just sign out. All right, so any question on that one? Just remember, it's all with graphing. You're just trying to see where the two lines cross each other. All right, let's try. All right, let's try this one. Solve using substitution. So your first one is y equals 2x minus 3. And the second one is y equals negative 2x minus 7. So this one's just like the one we did in the warm-up. Okay, so see if you can take a minute, try to solve that, and then we'll take a look. All right, so when you're solving with substitution, my hint is always to put parentheses around something first. So which one of these equations has a letter by itself?
Both.
Both. Yep. So in the top one, what are we going to put parentheses around?
The equation.
What part of it?
The left side. Right side.
Yeah. We'll put parentheses around 2x minus 3. And what do we put parentheses around in the bottom?
The left side.
Yep, which is
The y.
the y. Now the top equation tells us a formula for y. Y equals 2x minus 3. What are we going to do with this 2x minus 3?
Put it into black.
Yeah, where?
On the bottom.
On the bottom. So the top formula tells you what y is, and you're going to use that information in the bottom one. So you're going to have 2x minus 3 equals negative 2x minus 7. All right, let's solve. I would say let's put all the x's on the left. Evelyn, how would I move all my x's to the left?
You got them.
Yep. What would you add on both sides?
2x.
Perfect. I'm going to add 2x on both sides. That's gone. And Lily, what's 2x plus 2x?
0? No, 2x plus 2x would be 4x.
So 4x minus 3 equals negative 7. Okay, since we put all the x's on the left, we got to put everything without an x on the right. Zach, how would I move that -3 to the right?
+3.
Yep, I'm gonna do a +3 and a +3. -3's are gone. That leaves me with 4x. What's -7 + 3?
-4.
Perfect, -4. And my last step.
You just divide by 4 and you get -1.
Divided by 4, and we get x is -1. Nice. Okay, so x is -1. And which equation should we plug that back into to find y?
The first one.
Okay, let's fill it back into the first one. Fill it back in right there. So y equals 2. In parentheses, you're going to put -1 minus 3. What's 2 times -1?
-2.
Good, -2. And my final answer for y?
-5.
Excellent. -5. Okay, so a pretty standard kind of case that we did last week. Now the last two, I want to try to look at one that has a no solution and one that has infinite. Any question on example 2? All right, let's try example 3. What method is this one set up for? Since it's x plus or minus, then a y.
Elimination.
Yeah, this is set up for elimination. So first thing we do is we check, do we have the same letter, same number, and opposite signs right away?
No.
No. So somehow we need two numbers to become opposites. So let's pick which ones we want to try to
You
eliminate.
can just easily do x. You
You want to eliminate
divide by
x?
4. Yeah.
Okay, so if we're going to eliminate x, the bottom number is a 32. What would the top number have to be so it would cancel out 32?
You would multiply by 4.
So what number are we trying to get right here?
Oh, 32. -32.
-32.
So that means you would.
That's the goal.
You'd multiply by -4.
Yes. So this is where you had like the box last week. And remember, we're trying to get a -32 to cancel a +32. That's the goal. We could have chose to get rid of the y's, but we chose the x's, so that's what we're going to do. All right, what's 8x times -4?
It's going to be a problem list here.
-32.
Actually, no.
What is it?
-32.
-32x. And what's -4 times -4y?
Positive 16y.
Positive 16y equals, and what's -4 times 20?
-80.
Yep, it's going to be -80. Did we multiply the bottom equation by anything?
No.
Nope, then we just copy it down. So 32x minus 16y equals 48.
This would be infinite solution.
Well, let's see. What's -32x plus 32x?
0x. So
This is gone. What's 16y plus -16y?
Cancel out.
That cancels out. Whenever all your letters cancel out, now it's a special case. Okay, that's how you know it's a special case. All your letters are gone. Now, we've got to put something on this side, but everything canceled out. So what's on the left side?
0.
Yeah, 0 equals, and now we can do -80 plus 48, and we get -32. Okay, at this point, we just have to interpret what that means. 0 equals -32.
Infinite solution.
Is that, what do you think about that? 0 equals -32.
No solution.
Not equal.
Those aren't equal. 0 does not equal negative 32. The only thing that equals 0 is what?
0.
0. And we don't have 0 on this side. We have negative 32. So what that means is this is false, which means, exactly, that's what we have to write down. No solution. No solution. So we're not gonna do this, but if I were to draw these two lines, how do you think they would look if I drew them?
What was the question?
If we know that this problem has no solution, we had a false statement. It means no solution. If I tried to graph these, what would they look like? Yeah?
It would be parallel.
They would be parallel, yes. Perfect. If you drew these two lines, they would be parallel.
It means it will never touch.
It means they would never cross each other. So if you graph them, that's one way to tell there's no solution, but we don't need to graph it. We can tell by just doing the algebra that we got a false statement, no solution. Much easier to do the algebra than it is to graph. Because sometimes to graph, it's hard to tell, especially if you have to scale your axes. Okay, any question on that? All right, let's try, I'm going to make up another one. We will do this under extra example A. Okay, I'm just going to change this. All right, so let's do 2x plus 3y equals 12. Okay, that'll be our first equation. And negative 8x minus 12y equals negative 48. Okay, and so let's solve it. All right, is this one set up for graphing?
No.
No, I mean you could graph it, but it's not. It doesn't have y equals mx plus b, so that's a lot of extra work. Is it set up for substitution?
No.
No. If it was set up for substitution, you'd have a letter by itself on one side, and in this case, we don't. So, what method does that mean it's set up for?
Elimination.
Yep, this is set up for elimination. So, first step. Do you already have same letter, same number, opposite signs?
No.
No. Then we need to make that happen. Okay, first step. Let's choose which letter we're going to focus on. Do you guys want to try to make the x's eliminate or make the y's eliminate?
Y.
Okay, so we're going to focus on the y's, which means we're looking at this. Okay, look at the smaller number, 3, and then we have a negative 12. We want to change this 3 so it would cancel negative 12. Does anyone see what you could multiply? Well, what number cancels negative 12?
4.
Negative 4.
So what number cancels
Oh,
negative
12.
12?
Just 12.
Right, positive 12. So somehow you need to make this a positive 12. How could you do it?
Is divide by 4. I'm sorry, by the way, multiply. 4.
Multiply by,
4.
yep, multiply everything by 4. Here, here, and here. Okay. What's 2x times 4?
8x.
So we get 8x. All right. What's 3y times 4?
12y.
12y. And what's 12 times 4?
48.
48. Did we multiply the bottom equation by anything?
No.
No. So what happens to it?
It stays the same.
It stays the same. So let's copy it over. negative 8x minus 12y equals negative 48. All right, so now let's add them up. What's 8x plus negative 8x?
Cancels.
This is gone. What's 12y plus negative 12y?
Cancels.
That cancels. Okay. Once that happens, you now know it's a special case. Okay? It's going to be one of two things: no solution or infinite solutions. That's the only thing that can happen now. What's left on this side?
0.
0. And what's 48 plus negative 48?
Cancels.
Cancels, and I get 0. So now I got 0 equals 0. What do you think about that statement? They do equal each other. That's true. Okay, so in the last one, that was false. In this one, this is true. True's not the answer. But it means, what do you think this means?
Infinite.
Yes.
Solution.
This means that this problem has an infinite amount of solutions. Now, if we were to draw this, how would it look if you drew those two lines?
Yeah. Top of each other.
Right, they would look like, one would look like this, and the other one would look like this. So they are the exact same line. So this is true, which means an infinite amount of solutions. Okay, so now you guys have seen a couple regular cases, like in the warm-up and then in the examples 1 and 2. And then examples 3 and 4, I gave you both the special cases. I'm going to give you one more. We'll do this one for example B. I will give you a hint. It's going to be a special case, but I want you to tell me if it's going to be the no solution or infinite solution. Okay? All right. So we're not gonna do it by graph, and I'm gonna use a different problem. Well, actually, I could use that somehow. Let's use substitution. I just have to change this a little bit. So it's y equals negative 2x minus 2, and y equals negative 2x plus 8. Okay, so let's just do the first step together. When you're doing substitution, we put the parentheses in. What would we put parentheses around in the top?
What was the question?
So where would we put parentheses in the top?
Around the y.
We're going to put parentheses around the y and the bottom.
Around the 2x minus 2.
Yep. And now what's going to happen with that negative 2x minus 2?
It's like multiply something.
No multiplying.
You put them in for the equation on the bottom.
Right. You're going to take the formula for y in the top and you fill it into the one in the bottom. Okay. So you tell me, what do you get when you do that? What's going to be our new equation when we replace the y on the left with the stuff from the top?
Negative 2x minus 2 equals negative 2x plus 8.
Okay. And now let's get all our x's on the same side. how would we move the x's from the left over to the right?
Add 2x to both sides.
Yep, you would add 2x on both sides. What's negative 2x plus 2x?
Cancels.
That cancels. And what's negative 2x plus 2x?
And that cancels.
And that cancels. So remember what I told you, when all your letters cancel, it's a special case. What's on the left now?
-2.
And what's on the right?
8.
8. Negative 2 equals 8. What do you think about that?
Not equal.
That's not equal. So what does that mean when you end up with something that's false?
It's a no solution.
That's a no solution. Now, look at the two original lines. What's the slope in the top one?
It was like opposite.
Well, just looking at it right there, what's the slope of the top one?
-2.
And what's the slope of the bottom one?
-2.
How do those two slopes compare? They're the same. And what do you call two lines that have the same slope?
Oh no, parallel.
Parallel. And what did we just say about parallel lines? Do they cross? No. So we really could have told right away, because they have the same slope and different y-intercept, when you draw these lines, they're parallel. That means no solution. Okay, so hopefully, kind of like the graphing and the algebra kind of start to come together a little bit, and you kind of understand how they're connected. All right. All right. So that's 5.4. So the homework for tonight, it might have some no solutions, might have some infinite, and it might have some regular. Okay, just like we did in class. Okay, so just a reminder, this is the last week for quarter 3. And the homework tonight is the worksheet on 5.4. So everybody know what homework for tonight is? 5.4? Got it? Okay.